Hey guys, this is Miss Banks, and we're going to get started with the Algebra 1 lesson 1.2 on independent and dependent variables. First, we're going to start with a couple of definitions. The first one is we need to define a variable. A variable is something that is able to change. And then a correlation is how two variables relate to one another. Okay, so we're going to go ahead and just jump right into looking at a couple of examples. These are your notes, so be sure and keep up or write this down or copy your notes on your own notebook paper. So we're going to underline the independent variables once, the dependent variable twice. So we're going to be underlining the independent variable once and the dependent variable twice. Then we're going to label the table of values and draw the correlation in relation to the given arrow. Okay, example number 1 is your test score you earned is dependent on the amount of time that you studied. I'm looking for my highlighter here. Here it is. Okay, this gives us a really good hint because it says is dependent on. And that's going to be kind of a clause that gives me a hint and helps me figure out which one is independent. An independent variable is something that stands alone or doesn't have to rely on something else to happen. Whereas a dependent variable, something else has to happen before this can happen. So independent variables happen first, and then dependent variables follow. That's a really good way to remember and be able to solve through a lot of problems that we'll encounter. Okay, so we're going to underline the dependent variable. Which one has to happen first? The time you study will affect your score, or your score will affect the time that you study. Okay, the amount of time that you studied will affect your score. So this one will happen first, which will be our independent variable, and this one will follow, which will be our dependent variable. Now we're going to go ahead and put this on the graph. We've seen this type of table before last year when we looked at the big H. So we know that X goes here and Y goes here. X is the independent variable, and we've just underlined that over here. So we know that that is the time that we studied. And then the dependent variable is our test score. Now I'm going to go ahead and explain really quickly what correlation is. Now, since this is the independent variable, we want to look at, okay, what if we let it increase or decrease? The amount of time that we study, if we let that increase, what will likely happen to our score? It will also increase. However, in the opposite direction, the least amount of time we study, our score will likely decrease. So this is going to help us figure out the correlation. Both of these are going in the same direction, and that is what we call a positive correlation. Okay, the next example, the time it takes to run a lap is determined by how fast you run, or the speed. So again, we have a really good hint, is determined by. We just need to figure out which one happens first, and that will tell us, since what happens first is our independent variable, we'll go ahead and underline that. Does the time we run a lap in determine how fast we run? No, it happens. You have to run before you can time anything. So how fast we run, or the speed, is what happens first, and then we can get our time on how fast we ran. Okay, so this is our independent variable. This is our dependent variable. Our speed and our time. Go ahead and mark those in. And again, we're going to see, okay, if our speed increases, what will happen to the time it takes us to run a lap? So if I ran really, really fast, I would actually take less time to run a lap. Whereas if I ran really slow, or my speed dropped, the time would actually increase. Okay, and these are going in opposite directions, and that tells us that this is a negative correlation. Okay, the next example is Number 3, the cost of pizza at a buffet is dependent on the number. Oh, there is a good hint for us again. Is dependent on. And it's going to help us determine which one happened first. The cost of the pizza at a buffet is dependent on the number of slices you eat. Hint, you pay for the buffet at the end of the meal. So they even gave us a written hint as well. So the cost of the pizza, will happen last. You eat at a buffet first, and then you pay for it. So this happens first, and then they charge you. So we're going to go ahead and write in our independent and dependent variables again. This is the amount we eat, and this is going to be the cost. I'm sorry, you can't see that. So the independent is how much we eat, and the dependent is the cost. So if we eat gobs and gobs of food at the buffet, our cost will remain the same. Now, if you're a little bitty person or someone who doesn't like, I don't know, seafood, and you're at a seafood buffet, you're going to eat a lot less. But the cost of the buffet is going to be the same. When the dependent variable remains the same no matter what I do in whether I increase or decrease my independent variable, this is what we call a constant correlation. And another example, we're going to go ahead and go to number 4. The button you press on a vending machine affects the type of snack that comes out. This is a really, really good example, and we don't have any keywords to help us determine what comes first. But I know that if I walk up to a vending machine, I'm going to push the button and then something will come out. So I know that I press the button first, and then the type of snack I want will come out. However, we can't increase or decrease because this is not something of value. So when I go over here to the graph, I still have my dependent and independent variable. The independent variable is going to be the button I choose to push, versus the dependent variable, which is going to be the snack that I get once I push the button. Now if I increase, you see how you can't increase the button that you push, you can only push one button. So in this case, since we can't increase or decrease the variable, that means that there is no correlation. No correlation. Okay, let's go ahead and go to a few more examples. Number 5, we're going to identify the two variables. A carpenter's wage is a one-time service charge for $50 and then $75 per hour. We need to figure out what are the variables. And remember up top we said the variable is something that's able to change. This $50 charge is not able to change. This $75 charge is not going to change either. The variables are actually the wage that the carpenter is going to earn, and that happens after he works a certain amount of hours. So there go our variables. And down here on this graph, you'll see number 5. We need to go ahead and fill in. We know that this is X and this is Y from last week in class, our discussion. So the wage will be dependent on the number of hours. This depends on this. This depends on this. Go ahead and try number 6 together. David's savings account balance increases each month by 4.5%. Again, this is a number, and it's real easy to jump towards those numbers in math, but that's not the case here. That's not a variable. That that percentage amount will not likely change. It won't change. So we need to know we have his balance in his savings account, but we can't know the balance until we see how much he's saving each month. So it's the number of months and the balance. His balance will depend on the number of months that he deposits money into the account. The last one is a teenager's height and the month of their birth. the teenager's height, and the month of their birth. I don't know which one of these comes first. So again, there's no correlation. We really can't put this on the graph.